In this video, I'm going to talk about solving right-angled triangles. What does this mean? It means solving a right-angled triangle means that you're given a right-angled triangle with certain clues and you are asked to find a mystery side or find an angle, a mystery angle. Okay, let's jump straight in. Example 1. Here is example 1. We have a triangle. Notice it's a right-angled triangle. We're given one of the sides is 15 centimeters. We're given one of the angles is 40 degrees. And we are asked to find out what x is correct to 2 decimal places. So calculate x correct to 2 decimal places. Now, the first thing to realize here is always ask yourself, if it is a right angle triangle, can we use Pythagoras' theorem in this particular question? Have a look, pause the video. Can we use Pythagoras' theorem? Okay, the answer is we cannot use Pythagoras' theorem here, because if we wanted to use Pythagoras' theorem, we would have to know the length of 2 sides. If we knew this side and knew this side, then we could use Pythagoras' theorem, but we only know one side. So when you only know one side, it's impossible to use Pythagoras' theorem. So what we're going to use is we're going to use sa, ka, toa. How we decide which one we're going to use? Well, we label our triangle first of all. So if this is my right angle, then 15 must be h. Because I know 40 degrees, I'm going to call the angle or the side that is opposite this angle O for opposite, and this is the adjacent. I then tick the ones I know. So I know what h is, I know what O is. I don't know what A is. So looking at Sokotoa, which of sa or ka or toa, sine, cos or tan, which one has O and H in it? Which one has O and H in it? Okay. Remember, I know H and I want to know X. So sorry, I said I knew X. I didn't. I want to know X and I know H. So I want these guys. So I'm going to choose on this one, I'm going to choose sine. So what we do next is we write the sine of 40 degrees must equal O over H, which in our picture is x over 15. I'm going to write this out again a little bit neater. I'm going to say the sine of 40 degrees is x over 15. And I have an equation here. What I'm going to do next is I want to find out what x is. I want to get x on its own. What is this 15 doing to the x? What does x over 15 mean? It means x divided by 15. So how do I get rid of a divide by 15? What's the opposite of dividing by 15? Well, the opposite of dividing by 15 is multiplying by 15. So what we do is to get rid of a divide by 15, we multiply across by 15. So the 15 comes over and cross multiplies. So we get 15 multiplied by sine 40 degrees. And when you see something like this, like a number in front of a sign, it means the number in front is being multiplied by sine 40. So all I have to do now is I can write x equals, and all I have to do is type this into my calculator. But before I do that, I must check my calculator is on degree mode, degrees. Then I type 15 sine 40 close bracket. Double check I've typed it in correctly, and then press equals. And up comes my answer, 9.6418. Now, correct to 2 decimal places, it's 9.64. So I'm going to write 9.64. And to get full marks on this question, I must put the units in. Because it was given in centimetres, it's centimetres. And that there is the answer to the first example. Let's do a second example. Okay, in this second example, we have to calculate y correct to 2 decimal places. So what we have is we've got a right angle triangle, we got 10 kilometers here, and we want to figure out y here. So again, we cannot use Pythagoras' theorem because we only know one side. So we go straight to Sokotoa. Now, let's label our triangle. Because this is a right angle, this would be h, this is 30 degrees, opposite that is O, and then y must be the adjacent. Let's tick the one we know. We know what h is. And let's tick the one that we want to know. We want to know y, which is a. So I'm looking for something with a and h in it. So I'm going to use cosine. And I write cosine 30 degrees equals a over h. So cosine 30 degrees will be my a, which is y, over my h, which is 10. Now, a bit like the last example, I don't want y over 10, I want y. So how do I get rid of a divide by 10? By bringing it over and multiplying it. So it's going to be 10 cos 30. And I just can type that into my calculator. So I'm going to type in 10 cos 30 degrees, press equals, and 5 root 3 comes up on my calculator. Now, because the question wants it in decimals, I'm going to press my SD button. And I'm going to round it off to 2 decimal places, 8.66. So 8.66, and it's kilometers this time. There is my answer to that example. One final example on this video. We have another triangle here, 35 degrees, 5.7 centimeters, and a Q, and we're asked to calculate Q corrected 2 decimal places. Again, we cannot use Pythagoras' theorem because we only know one side, but always ask yourself, because Pythagoras' theorem is easy if you can use it. So I'm going to label my triangle. I'm going to label this triangle. There's my right angle. This is H. This is O, and this is A. I know what A is, and I want to know what O is. So which ratio, sine, cos, or tan, has O and A in it? The answer is tan. Tan of 35 degrees is O over A. So tan of 35 degrees will be my O number, which is Q, divided by my A number, which is 5.7. But I don't want Q divided by 5.7. I want Q. So to get rid of a divide by 5.7, we cross multiply. And all I have to do is type that into my calculator. 5.7 tan 35 degrees. Double check I've typed it in properly and press equals. And up comes 3.991. Now they want to correct to 2 decimal places in this particular question, so 3.99. Check my units. It's going to be in centimeters. And there you have it. There is our answer to that one.